Good afternoon, everyone. Thank you for joining us. We'll go ahead and get started in just a couple minutes as people continue joining the Zoom. Good afternoon. Welcome to the next member hour in our AE50 series entitled Precision Planting presents Radicle Agronomics. My name is Sarah Rodriguez, and I'm the host of this session today. ASABE member hours were started as an opportunity for our members to learn, connect, and grow. In a few minutes, we'll get things started, but first, just a few quick second ground rules. Please do keep your audio on mute throughout the presentation. If you have any questions, you can type them into the chat throughout the presentation, and we'll also be opening up for verbal questions during the question and answer segment. This meeting will be recorded, and it'll be available for later viewing on the ASABE website. Today, we're hearing from Reid Harman, an R&D engineer from Precision Planting. Reid is presenting the 2023 Davidson Prize-winning technology, Radicle Agronomics, a new generation of powerful tools enabling professional agronomists to focus their time on agronomic issues faced by growers. It's all yours, Reid.
Okay, thank you, Sarah. So hello, everyone. Like Sarah said, my name is Reid Harman, and I'm in Tremont, Illinois. This is the headquarters of Precision Planting. So during this presentation, you'll see the name Radicle Agronomics many times, and think of Radicle Agronomics as a brand of Precision Planting. So just to be clear, it's the same company. I work for Precision Planting, and I am on the Radicle Agronomics team. So the title of today's presentation that I put is Challenging the Status Quo. So this is meant to be a presentation for professionals, for engineers like yourselves. And so I want to use it as a little bit of a teaching point to kind of relay some of what I continue to learn as an engineer at Precision Planting. But we're going to get to Radicle Agronomics. But first, let me just touch on kind of the philosophy, if you will, behind the development that led up to Radicle Agronomics. So before I get to Precision Planting, I just want to highlight that I am in agriculture because I grew up in agriculture. First the agenda slide. So this is what I meant to show a moment ago. So we're going to talk about philosophy a little bit, then intro to Radicle, and then our future research, and we'll have time for questions and answers at the end. Feel free to add them in the chat at any point, but I'll probably get to all the questions at the end. So again, I was born into agriculture, and so like many of you, I have a passion for it. I care about it because I understand it. I'm connected to it. So this is just a view from the roof of one of my family's grain bins. So it's in central Illinois, not too far from here. And it may look similar to some farms you've been to, or it may look very different. I know that agriculture is very diverse around the world. But this is a photo of me, my brother, my father, and my grandfather. So there's a few generations involved in farming in my family. But I wanted to start with this because, one, again, agriculture is about people. So we always want to make sure we're helping people. But this planter in the background that you see here, that was one of the recent developments on my family farm. And so this was a few years ago. We bought this John Deere 24-row planter, and we were putting some precision planting equipment on it, as you can imagine. So one thing that we put on it, one thing that we've never invested in the past before this was Downforce Control on a planter. So just a little bit of background there. Downforce Control, if you're not familiar with the planter, is essentially to manage how much weight you're transferring from the planter itself to the individual row unit. So this is a row unit, and I chose a case row unit here because of the company. We embrace all colors of iron. So here you can see on this particular row unit, there's basically 4 points where the row unit touches the ground and transfers weight to the ground. So on my family's farm, we did not have any control systems that managed how that weight was transferred. And so that weight has a big influence on crop emergence because it controls seed to soil contact, or compaction around the seeds. So with my family's planter, I said, you know what, let's start investing in downforce equipment. And the first thing that we did was we added load cells to each row unit to simply tell us how much weight the gauge wheels were carrying, the gauge wheels in the middle of this photo. And so we did not have any control systems. We just had a monitoring system. And that's a precision planting product. But how do you think we did, or what do you think we saw when we had a monitoring only system on Downforce, something that we had managed just essentially by eye for years prior? Well, to give you a hint, red is bad on a map. And so this is one of my family's fields that we farm. And you can see here that we had issues, we had problems. And the reality is that we knew this was a difficult thing to manage, but we thought we were managing it fairly well up until this point. But in reality, we were not. And it took us having something to really tell us, a measuring tool to tell us that we had a problem, right? So as engineers, we can appreciate this. If you have a caliper or any other tool, you're taking a measurement, you need a good measuring device in order to give you good information that then you can act upon. So on my family farm, this was you can see in 2019 we were planting corn, and this was the map coming out of one of our fields. Now this was very typical. It's not like this was the only field that had red. This was a common phenomenon. So we were generally applying too much downforce, which means we were causing unnecessary compaction around the seed. So then fast forward the next year, we added the control system, not just monitoring. So once we added control, here's what that same field looked like. Okay, so again, as an engineer, this makes me so satisfied, right, to see this, to know that this is actually on my own family's farm, that we were able to make this improvement. So this is essentially managing the compaction of the soil very, very well. So this is just an example of what we try to do in product development. We try to, what we say is, shine the flashlight on products or on issues that exist out in the field. Sometimes we don't even know that we have an issue, right? And sometimes even as engineers, we don't even know there's an issue. But that is a really important part of any development cycle, is to go out, meet the people, understand the issues, and then try to educate on those issues. Okay, so this is just a way of introducing kind of the philosophy of precision planting. So how do you educate? Well, by any means necessary. So this is one thing that we used to do periodically as a company. We would host an event and we would just dig down and do essentially root pits to show, okay, if you are changing your downforce or changing your population or changing your depth, how is that affecting the plant beyond what you can just see from the highway? When you actually get down and assess the plant, what are the effects of your actions? And so again, this is shining that flashlight. It's educating, and it takes time, it takes effort. But as engineers, we are part of this process to identify issues and to figure out how to convey the importance of solving the issues. Okay, so kind of shifting, we're shifting now from philosophy to products. And you can see here, this is just a plot showing Precision Planting as a company, the products that we developed as we understood more and more issues and were able to devote resources into solving those issues. So again, from an engineering perspective, it can be satisfying, albeit a bit daunting, to try to take on all of these issues that you identify in the field. But that is really the amazing part of agriculture, is I feel like you get a very hands-on tactile experience when you finally solve that issue. So these are some of the products that we have developed over the last 15 years or so. And right in the middle is a product that I want to highlight because it's kind of segueing into Radicle Agronomics. So right in the middle, there's a product. Oh, I'm sorry. Yeah, all these are meant to essentially take guesswork out of the performance in the field. But back to that plot, right in the middle, there's a product called SmartFirmer. So SmartFirmer was really an interesting product for us as a company because it was the first thing that was really measuring soil as opposed to just measuring the machinery itself and how the machinery is interacting with the soil. This is really a soil-focused tool. And for the first time, it really enabled many farmers to get a high-resolution map of their soil in a field. Now, we as a company, we don't want to oversell this product, but a lot of people wanted us to be able to tell them everything they would ever need to know about their field. And so, we were, as engineers and as marketers, we wanted to make sure not to oversell the product, right? This cannot do everything in the world, but it can give you really good relative organic matter maps of soil moisture, and maps of crop residue that's incorporated into the soil. But what a lot of guys wanted, what a lot of farmers were asking for was, well, how do I get nutrients, right? Once you start to get a map of your soil, the traditional way people look at soil maps is in preparation for nutrient application or nutrient management, right? They want to know the fertility of the soil. And organic matter, there's a correlation there between organic matter and fertility, but it's not a direct measurement. But lots and lots of guys kept asking about it. And we realized after, years of feedback that, hey, maybe this is another one of those problems, right, that we are trying to identify. So maybe this is a flashlight moment and we just don't understand it well enough yet. So we wanted to better understand, why so many guys wanted to use a SmartFirmer for nutrient management or to be able to. And so if we look at the kind of the finances of a farm, a really large fraction of expenditure is for fertilizer. Okay, and that's probably not surprising to anybody because fertilizer, it's in the news a lot. It's in if you just keep up with markets, a lot of times the cost of fertilizer comes up in conversation. But the fact of the matter is that even though it's the largest consumable input in a farm, it's also one of the least understood inputs. There's not many people that feel like they really understand how to be an excellent steward of fertilizer. And speaking of stewardship, the scale of this problem is pretty amazing. So, globally, we use somewhere around 220 million tons of fertilizer. This is our estimate as a company, and that essentially amounts to a freight train, a string of rail cars hauling fertilizer that goes around the entire globe every year. And so, there's a lot of material that's being moved and a lot of expense in that that farmers are carrying. So when it comes to managing that fertilizer, how do you really do that today? So that's again, we wanted to understand where people were at, understand the issue. And so today, if you want to know, how much phosphorus do you need to apply, or how much, MAP or DAP or nitrogen, the way you do it is with a fertility recommendation, and that starts with soil sampling. So soil sampling does what SmartFirmer does not do, right? SmartFirmer does not measure elements in the soil, but soil sampling does. You collect a sample of soil and you ship it, you mail it to a laboratory, a soil analysis laboratory, and then there's many of these in the U.S., many labs in the U.S., and then they will manually process it through a chemistry lab, much like a chemistry lab that you might have had in school. And so those people then, those laboratory technicians and chemists, they analyze the soil, and they give you feedback, or they give you information on your field in terms of what the current nutrients are. But we wanted to understand what that looks like. And so here are some photos of soil samplers in the US in the early 1900s. And the interesting thing about this is that precision planting does a lot of soil sampling because we manage a lot of research plots. We essentially run a farming operation every year just to manage our research plots. And so we collect a lot of soil samplers, and these old photos really are not that different than our own experience and what we saw today when we went out and visited farmers and agronomists. Soil sampling has not really changed all that much. But again, we wanted to ground truth that, and so we went out and spent a lot of time with guys out in the field, understanding what current agronomists, current soil samplers, what they see as the problems, what they wish were better. And then we also were just observing them and making our own determinations, if you will, we would identify issues that maybe they would not even realize they were issues, but as a fresh set of eyes, we could be a little more scrutinous and say, well, wouldn't it be better if this was not part of the process, or if this was part of the process? And so, that sort of feedback, those conversations, again, with the people that are being affected, were very helpful in the early development process for what ultimately became Radicle Agronomics. So if we want to look at, if we want to improve the process if we want to improve the process, we really need to understand what the current process is, once again. And so this is essentially a really simplified version, but very accurate, of the current nutrient management cycle. So again, a lot of guys were asking for our help, and so we wanted to see, how can we help? And so, again, identifying, getting a baseline, understanding what the current marketplace looks like, that's an important part of the early development process. So the nutrient management cycle essentially has 4 steps. You collect soil, you analyze the soil, you build a recommendation, a fertilizer recommendation off the results of that soil analysis, and then you go apply your fertilizer, whether it be dry, liquid, broadcast, strip till, strip application. And then ultimately you turn around, whether it be the same year or 4 years down the road, and you reassess. So this is a continual cycle that farmers and agronomists go through. And generally, the feedback that we got, the impression that we got from everyone is that, hey, we're doing the best we can. Like, this is the only option that we have, is to use the tools that are in place today. But the unfortunate thing is that basically no one had confidence in the current way of managing nutrients. So it was there was an utter lack of confidence, but also a lack of options. And so we saw it as, okay, we need to try to offer a better option. So that's where Radicle Agronomics was born. And essentially, we have kind of 3 goals: offer better tools, better data, get better data from those better tools, and help farmers and agronomists make better decisions. So that really, the Radicle platform involves 3 main components. And that is to the left here on the screen, the application, the software side that allows everything to be really streamlined for everyone in this process, because nutrient management is fairly complex today, and one way to simplify that is to simplify the kind of the workflow that's involved, to make it easy to get your information, easy to make decisions. In the middle here is the infield portion of the system. So the Geopress is to help soil samplers collect better soil samples, and I'll get more into that later. And then on the right is the Radicle Lab. So the Radicle Lab is the soil analysis component of this system. So it is a hugely important, it's really kind of the heart from a machinery standpoint of the system. So then let's look back at that cycle. So soil sampling is the first step in that, let's say. That's when the soil actually leaves the ground. And so that's where Geopress comes in. So Geopress can go on the back of an ATV, it can go on the back of a UTV, and that again is trying to meet the farmers and agronomists and soil samplers where they're at. We considered other options, in development. We tried so many different variations of this, and oftentimes what we found is that in developing these products, you kind of have to be careful not to make your customers too uncomfortable with machinery that feels too unfamiliar, let's say. And so it was a compromise between engineering and psychology in a way, to say that okay, we need to offer something that feels fairly familiar, that meets people where they're at, but still gives them those better tools. And so here you see it on the back of an ATV. Here you see it on the back of a John Deere Gator. Any UTV works as well. So the way this works essentially is you collect soil however you currently do. So most guys use a probe similar to the one shown here in the right, in the photo on the right. And so you collect soil with a probe ideally, and then what guys typically do today is they'll like tap it into a bucket as they go. So they'll pull some soil out of the ground, tap it into a bucket, pull some more in another location, tap it into a bucket, and they'll get maybe 4 to 8 cores. So they'll push the probe into the ground 4 to 8 times, and then all those cores will be in that bucket. And essentially, then on the Geopress, we have a door that swings down on the left side there. You can see there's a horizontal handle, and you swing that door down, dump the soil in, and it goes through a homogenizing blender, and it's very, very fast, almost instantaneous. And it then redeposits into a cup that you then pour into the funnel on the right side. And once you pour it into that funnel, the soil sample is then officially collected, and the homogenized soil now gets stuffed into a geotube. So introducing the geotube here into the conversation. So this is a small but pretty important part of the system, in that it's our soil container. So what you see here is essentially a plastic tube with a cap on each end. The black cap is where the soil enters and exits, and then the white cap on the bottom is actually a piston. And so that allows us to eject the soil from this container. And we tried various different containers. Again, just to kind of clue you in on the development process, we tried different shapes. We went down the disposable route at one time, and in the end, it felt like the right thing to do was to make a durable container that was reusable. And the trick there with soil is that it gets dirty every time you use it, and so we have to automatically clean it in the system every time that it gets emptied. So that was kind of the feature that allowed us to go this route, is that we can have a durable, reusable container because we clean it with every sample. The white dot you see on the bottom cap there towards the left of the screen, that's an RFID tag. So from a development process, it was a new experience for us to go into the world of RFID tagging, but we essentially got to where we can really reliably read and write and transport them, and so we have it's turned into a very valuable feature for us as well, because all of the information on that sample is automatically saved to that tube as soon as it's loaded. So there's actually no hand documenting of anything in this entire system anymore. So as soon as you collect that sample from a field, it saves all that information to that tag. It saves the lat long of where it came from. what client it's for, who was the sampler, what was the time, etc. So anyway, automation is a big underlying theme in this whole system. So this was a really useful step in that process. So if we go back to the management cycle, soil analysis is the next step, right? So once we get back to the office, let's say, so the soil sampler goes out and collects some soil. He then comes back and brings the tubes back in one of various containers. On the left here, you can see a bunch of tubes in milk crates. It's actually a very nice way to transport them. And which I'll just make a note from a development standpoint, that was another thing of meeting people where they're at. There are guys that today use milk crates to transport soil, and so this was a great way again to kind of meet them halfway, give them a new tool that doesn't, or that allows them to kind of reuse some of their existing experience and knowledge. So we get back to the lab, and the tubes get loaded onto the rack next to the lab, and so they then automatically feed down to a conveyor that processes the soil. So a soil sampler or agronomist, all they do is they load the tubes onto the rack and then essentially hit a play button, and that's it. So it's all automated from there. But as you can imagine, there's a lot going on from an engineering standpoint. So let's kind of dive into this a little bit more. What do we want the lab to do? What is the goal for the lab? So we want a soil sample. In our mind, a good soil analysis is accurate, repeatable, and efficient. Okay, so these are kind of the three requirements for a valuable soil analysis. So what does a typical lab do? Because, you know, up until this point, I have not really commented on why the current system that's in place in the US and the world, you know, why is it insufficient? And I'll get more into that actually towards the end of the presentation, but let's just look at what the typical workflow looks like in a lab, and I'll comment on some issues there. So typically soil is brought in a bag, and so the lab would receive a bag and remove the soil from the bag. They then dry the soil in an oven, and unfortunately, this is where the issues start, because when you dry moist soil, which coming from a field, there's always some level of moisture in soil, and when you dry that down artificially, you actually start to change the extractable nutrients from that soil sample. Potassium is really well known for this. It's a particularly bad example, or good example, I guess, for this example. But the potassium results can vary, say, 50% with dried soil versus moist soil. So drying the soil just adds error to every sample. How much it's dried varies. It's sort of an arbitrary amount. They basically dry it as much as they need to in order to have it sufficiently dried to work with. Because the next step is they grind it in a hammer mill, typically, and then they run it through a 2mm sieve, and it's then so then they have a cup of dried ground soil, so it's just like dust, you know, it's really fine powderized soil, and so they then take a scoop, and this is a measuring scoop, and they will scoop out and this is pay attention to the wording here. So they'll scoop out a known mass of soil. So the inherent issue with that is that soil varies quite a bit in density, but many labs, I'll say most labs, use a volumizing scoop to measure mass, and so that is inherently problematic because you don't really know the density of what you're scooping. So they use a volumetric method to weigh out, to measure a mass, and you have to hope that scoop that they got, which is about a thimbleful, represents the entire sample, which is more like the size of a baseball. So they try to scoop out a representative sample or subsample, and then they mix it with chemical extractant. So this is a time-sensitive step because the longer it mixes, the more nutrients it extracts, and then at hopefully the right time, they then transfer it through a filter to remove the actual soil, and it's left with a water-like liquid. So that is you've essentially pulled the water back out of the sample, and that water now contains nutrients in it. So the filtering is also a time-sensitive step because the extraction is still ongoing. And then it's run through a piece of analysis equipment, typically an ISE, and that's, it's a wonderful piece of equipment. It's one of the best instruments money can buy, but all the steps leading up to that are error prone. So the Radicle Lab, in comparison, the workflow through it is removing it from a geotube, and then immediately it changes, or it's different from the traditional lab. So we do not dry samples down, we wet grind them, and really that is just to break down the soil particles in preparation for analysis. We then wet sieve it, and right away then we start measuring it. And let me back up and say we wet sieve it because we still want to remove, corn cobs and, pieces of rock, anything that is really not soil. So we remove the foreign matter, and then we start measuring that moist sample. So we measure the volume of it, and then we measure the mass of it with a load cell. And so now we have the approximate density of it, but we even want to go a step further, and so we actually then measure the soil particle density of the soil. And what that essentially means is that if you think of the particles, the individual particles in suspension in the liquid, we are actually able to measure the density of those individual particles, and it helps us tell what type of soil it is that we are analyzing. So then we put all those together, and we're able to then calculate basically the precise amount of water that we need to add to this sample to get a target ratio of mass of water to mass of soil. And just to say that, these are processes that are not possible really in a traditional lab. So it's just the benefit of being an engineering team, designing a piece of chemistry equipment, is that you can make it do things that no one else is able to do, even though everyone would love to be able to do them. So again, just sorry, a little shout out there to engineers being involved in chemistry. So after we measure those things, we then dilute it with a prescribed amount of water. We then re-homogenize the sample to make sure that soil and water is really well mixed. And then we draw out an aliquot of liquid. And so this is our alternative to a scoop. So we want to draw a perfectly representative subsample that represents the whole sample, and you can do that with a liquid when you've homogenized the liquid. So we draw out that subsample, and then we run it through chemical extraction, filtering, and analysis, and these are all automated steps in the lab. So you don't have the error of human timing, manually transferring things around a lab. Okay, so this process is optimized for accuracy, essentially, instead of being optimized for workflow efficiency, in a lab with humans, essentially, right? With chemists and technicians working with all these samples. So the beauty of automation is that you can really dial in the accuracy, right, without sacrificing efficiency, essentially. So anyway, so this is an overview of the process that the Radicle Lab goes through with every sample. So then after it's analyzed, well, just a shout out here. So in the analysis portion, by the time we've filtered our sample down, we're dealing with very small volumes. And so just to highlight kind of the I guess the cool factor from an engineering standpoint is that we're dealing with microliters. And so a microliter, so the picture on the right is like a typical eyedropper drop, and the drop on the left is a microliter. And so, about the size of Lincoln's nose on a penny, you're really doing precise work when you can automate it with this sort of equipment. But anyway, the results. So after analysis, you need to be able to show those results. That's the whole point, right? Is to help people understand their soil. And so then we essentially create reports, which again is a familiar form in the world of agriculture. This is what a farmer or an agronomist would expect to see today from traditional soil lab. Even though the whole workflow is different, we do again want to meet them where they are and give them something familiar. And so this is a printout essentially of their soil analysis. So then back to that workflow, the next step after the lab is the recommendation, right? And that's where honestly, there's just not a lot of confidence today. There's the lab work, there's error that comes out of traditional labs, but we at least can kind of understand that. We can quantify that and then try to reconcile it. But when it comes to the recommendations, we know that they're not really that accurate. There's a lot of room for improvement. Essentially, they're educated guesses at best, but we're not really, people aren't equipped with better options. And so with the Radicle platform now, we see that we recognize that really the next big hurdle is to provide better recommendations or empower people to get better recommendations. So let's look at what a typical soil recommendation might look like today. So first, we'll look at results, and this is again, to understand kind of what is the current state for nutrient results and why do we see the need to offer something better. So this was a portion of a field that we analyzed. So we have a chemistry lab with chemists here at Precision Planting, and so we said, okay, we want to do a human-to-human study to say, what can our chemists do? And they are being extremely careful in their work. So we're going to say that no one is going to analyze these particular samples better than them. So they will be our baseline. And so this is what a portion of this field looked like when it came to analyzing the phosphorus of the soil. And then we sent the exact same soil to another lab, and this was the map that was generated with their data. So pretty similar. This was a second outside lab, and again, they were offering pretty similar results. And then this was a third lab. So the third lab, again, looked pretty similar, starting to look a little unfamiliar, but overall you can kind of see a common pattern here. So this is phosphorus. So then and the question is, which one is right? Like if we're trying to get to truth, and every different source gives us different information, it begs the question, well, which one is right? Which one is truth? So then if we look at potassium, it is a different story. It's a pretty bad comparison, or there's very stark contrast between some of these maps. And again, the question is, which one is right? So this is the information that guys are getting today, that farmers are getting today, that agronomists are getting today. And this is why there's not confidence in soil recommendations, is because even from the lab standpoint, if you want to say, okay, I just want to understand where my soil is today, you're not going to get that confidence if you realize that every lab is going to give you a different answer, different result. But when it comes to recommendations, that's the next step, right? So if we take these maps, the phosphorus map that you just saw and the potassium map, and we convert them to a recommendation, or we run them through a recommendation. So these are the maps that we generate. So this is the applied fertilizer map. And you might think green is good, but think of green as expensive. Green as dollars. So the more you're applying, the more money you're spending, the greener your map is. And you can see that the way that it worked out was that if you look at the bottom of the screen, so the Precision Planting Lab had a baseline expense, fertilizer expense. The external labs were all, for whatever reason, more expensive in their fertilizer recommendations. So Lab 1 was $1,200 more, and Lab 2 was $287, and Lab 3 was $1,758. Okay, so this is a small portion of the field. This is a very small portion of the field. So it's about 15 acres or so. So you could say that worst case is Lab 3 is about at $100 per acre more expensive on their fertilizer recommendation. So this is using, the recommendation systems, options that we have today. And again, the question is which one is right. So we want to develop a better recommendation system. Now that we have better measuring tools and we're starting to shine that flashlight, we now, as engineers, want to say, okay, well, it doesn't feel right to give someone a downforce map that's all red, right? And just say, oh, well, now you can measure your problem and you have a problem, but we don't know what to do about it. So now we're starting to see that there's a problem, right? Now everyone is starting to able to see that there's a problem. But the question is what do you actually do about that? How do you bring clarity, in this case, to fertilizer recommendations? And what you have to think about is that this is kind of where we are today, is that if you want to say, okay, what should my fertilizer recommendation be? You have lab A, B, C, all the labs in the world, basically, they will give you fairly consistent recommendations within themselves, but none of them are actually the truth. None of them are accurate as well as consistent. And so the question is, well, what is accurate? Surely there's some lab that's accurate, that would give you an accurate recommendation for fertilizer. And there was a lab that was accurate, and it was the lab that did the research on crop calibration response. And unfortunately, that lab doesn't exist anymore. And so this lab in the photo, every university, or not every university, but a number of large, land grant public universities did this research. But like I'm in Illinois, the University of Illinois did this research in the 40s. So the lab they used was their lab. It was Dr. Bray, if anyone's familiar with Bray extraction method. He did a crop calibration response, but Dr. Bray is long gone, the lab is long gone, and so there's no way to use that crop calibration data with any existing lab today. That's where it's just the information is not there to sync those things up. And crop calibration research is very intensive research, because if you want it to apply to a wide area, you have to do these studies over a wide area and wide geographic area. But that is what we envision doing here. So what we want to create is essentially the world's first modern crop response that is correlated to a lab, so that you know what the relationship is between the crop response data, in other words, how much fertilizer you need to raise your target yield, and how do you tie that, how do you relate that to the information that you're actually getting from a soil analysis report. And so what we envision, what we're in the process of building is a family of these labs that are all clones of each other. And so they are, again, sort of like traditional labs, they're consistent within themselves, except instead of being consistent within one geographic location, because they're machines, they're clones of each other, they can be consistent across any geography. right? So it allows individual agronomists to have their own analysis equipment. But as we build the crop calibration data, it relates to all of the labs everywhere, and so it's a huge undertaking. But we are investing in this research, and I mean it's very intensive research. But we've collected tens of thousands of soils that we are analyzing for both what is their current nutrient and what is their growing capacity, and how do they respond to fertilizer. And so it's an enormous effort, but we as a company feel that it's the right thing to do. It's what the world of agriculture needs. So then one of the things that limits you is essentially the calendar, right? The seasons. And so to get around that, some of our research is now ongoing inside of a greenhouse that we have here in Tremont, so that we can continue to get information year round and not just be limited to the narrow window of fall and spring. And again, the overall vision here is that we allow farmers and agronomists to better manage their soil, to avoid wasting money, applying fertilizer that's unnecessary, but also to avoid starving the crop. This year, was a drought year in central Illinois and much of the Midwest and even beyond. And so it became really apparent when the soil got really dry, that some zones were under fertilized. They were not able to access the fertility that was there because of the lack of moisture. And the way that fertilizer was applied and the quantity of fertilizer, really had a huge impact on that. So it just goes to show the importance of optimizing your fertility program. And I'm not saying to plan for droughts, but to plan for whatever might be around the corner, because it's really expensive to waste fertilizer, and it has a negative impact on our ecosystem too, which ultimately is going to bring more regulation into agriculture. And so, if we're better stewards of our resources, we're more likely to maintain independence as well. So it's a huge opportunity. And as a company, we're putting our full weight into trying to make a difference in this space to equip agronomists with better tools to help farmers in the end. So the thing that ties all these together again is the app, the software in our system. And this is, I'm really, as an engineer, I'm helpless when it comes to developing software, I'll say. But it is really awesome, the guys that I get to work with that they make all this stuff, and we work side by side every day, and it's an honor to work with some of these guys, because it really makes you appreciate people of different talents than yourself. Same thing with our agronomy team. I'm not an agronomist, but I work with them all the time, and it's just really satisfying to see all these people come together and bring their prowesses, kind of to a united front. So I'm just going to wrap up here and say, again, this is about challenging the status quo. So that was the title of my presentation. And we as professionals, we really have an opportunity to make a difference. We have the opportunity to identify the problems and do something about them. And I mean, it doesn't get much better than that. It can be really hard, and it can take a lot of time, and it can take money. But passion is probably the most valuable thing that I find in anyone. Is when somebody cares and then is willing to do something, and power through the difficult times, and relish the good days when they come. So anyway, just a couple quotes here that I like. So the people who are crazy to think they can change the world are the ones who do. I think there's some truth in that for sure. And then and as an engineer, this is probably even more important for me to remind myself: you miss 100% of the shots you don't take. Just because there's a risk of failure, it does not mean that you should not try. Take a chance once in a while. So anyway, wrap up with people again. So this is my family back on the farm, and again, we're about people. Agriculture, it's one of the largest employers, and we feed everyone else that does not work in agriculture. So it's just all about people. So we try to keep that in perspective. With that, I will end my presentation and open it up to any questions.
Wonderful. Thank you so much, Reid. And I hope you all join me in thanking Reid for an interesting and informative presentation. Do we have any questions anybody would like to unmute for? If you'd like to send anything in the chat, that's also welcome. Okay, here's one. Is SmartFirmer an available product?
Yes. So SmartFirmer is a product that we've sold now for several years, and it's available currently on an assortment of so it's meant for planters, so it goes on the row unit of a planter, and it's compatible with deer planters, compatible with Kinsey, really a number of planters around the world. So if you have any specific questions, or if you know of someone that might be interested, you can actually call our company phone number anytime to ask questions about compatibility or availability. We don't sell products direct, but we have a team of educators that are happy to answer questions. So the phone number, I'll just put it in the chat right quick. So the phone number for our company is 309 925 5050. And just to say, the phones are always open during the workday. So it is an available product. I see a couple of questions in the chat here. So the first one is it realistic that we would ever be able to take the agronomist out of the loop? So as a company, we think that's probably not wise to take the agronomist out of the loop. The challenge in agriculture is that every field is different. Every farm is different. I've gotten to travel the world a little bit, and it's just so variable that if you try to centralize agronomic knowledge, then I don't think that normally goes very well. So it's sort of like in government, right? And not to get political, I just mean from a sociological standpoint, there's normally the feeling of the further away your representative is, the less you feel connected, and the less you trust their opinion, perhaps. And so in ag, it's the same way. Every farm is different. We even hear, if we're 100 miles away, and we say like, oh, well, we test in, southern Iowa. Someone will say like, oh, well, that's nothing like northern Iowa. And it's just when it comes down to it, like, you really need local connections. And so we do not want to take agronomists out of the loop. We think it's really important that every farm, every field has someone that is helping steward that directly. Next question was, what is the cost per sample? So we as a company, we're not a lab, like a traditional lab that just sells individual samples. We're making the equipment, and then we are right now what we're doing is we are then leasing the equipment to agronomists, to soil samplers, consultants, and then they run it sort of like their lab. We handle all the maintenance, but like the cost per sample, it's in many ways up to them to determine what makes sense for them. But I would say, generally speaking, it's pretty much equivalent to a sample cost today that you would pay, what you would pay at a traditional lab. I would say pretty much equivalent. There's another question here. thank you for the compliment. Back to your family farm example from 2019 and 2020, can you comment on any correlation you saw between downforce consistently and yield change? Oh, that is a great question. I should have brought up the yield maps. So I don't know how that turned out in that field. What I would say is that on my family farm, managing downforce has led to better emergence, more consistent emergence, and yeah, less compaction. So we've as the years have gone on, been better about draining our fields, so draining wet spots to help minimize compaction, because when you go through a wet spot, you tend to over compact the soil. And the downforce management has also helped a lot with that, to where we can minimize compaction to make sure that we're not getting like hatchet roots or even just preventing emergence completely. So I would say that the obvious wins are like in terms of managing compaction and therefore promoting even emergence of a crop. But yeah, I'm sorry, I don't have the yield data on those fields. Could you explain the sensors that measure the volume and particles density? Thanks. Sure. So to measure the volume, yeah. So the volume sensor. So there's a volume sensor, mass sensor, and particle density, essentially sensor. So the mass sensor is a load cell. Volume sensor is an ultrasonic proximity sensor, and excuse me, the soil particle density is actually measured with like a narrowband spectrometer. So we're monitoring different wavelengths and monitoring how those wavelengths of light are reflected or absorbed by the particles. Let's see, I think there's a couple more questions. What is the least amount of time from sample collection to recommendation you think is possible with trained process groups? Literally like a few hours or less. I mean, technically it's like 20 minutes. But practically speaking, same day is very possible. Any thoughts on how your technology platform would play out in developing agriculture systems? So I am going to assume you mean like developing countries. So maybe like in parts of Africa, Asia, or South America. Yes. Okay. So yeah, personally, I'm really excited about getting to help developing countries with this, because in the U.S. we have access to soil labs. We have access to all the current options that I mentioned. They don't even have those options. Even though those are imperfect options, they do not exist in many parts of the world. Some parts of the world actually sterilize their soil and ship it to the U.S. for analysis. Yeah, that's going to mess up your results. But the point is that it's really hard to manage your soil or to assess your soil in some other countries. And so I look forward to someday offering this platform to those places, because it's going to be a huge difference, right? We're going to make a difference in Illinois and Iowa and the U.S. where we have alternatives currently, just not great alternatives. But yeah, when you talk about basically having no alternative, that's really unfortunate. So we're going to be going there, and I'm really excited about getting to help those people.
Reid, I've gotten a couple questions sent directly to me.
Sure.
The first is, who do you see the main purchasers of the automated lab? Co-ops, consultants, large fertilizer distributors?
So anyone that is today, that's currently in this trusted role with farmers of providing soil analysis results, fertilizer recommendations. I think anyone that's currently in that role could benefit from this. in the near future. I don't think we are. I don't think we're looking to go. Well, I'll just say trust is really important when it comes to fertilizer recommendations. So yeah, I think right now it's the people who I think are most excited about this and who we want to work with early on are the people that are currently in those trusted relationships with farmers, but need better tools.
And then another, is there any ongoing work on fully autonomous UGV system design?
UTV, like out in the field, like the John Deere Gator or something like that.
I suppose that's probably what they meant. Yeah.
Okay.
What I meant is unmanned ground vehicle autonomous system to
Mhm.
make the whole system fully autonomous to collect the soil samples.
Sure. So,
Thank you.
we are working on, and we've discussed this a little bit publicly. For a while we have been working on sampling equipment. Looking for what is a way to ease that part of the workflow, because that's where a lot of the physical pain is going out and collecting the soil samples. So we're still evaluating many different options there. We do plan on coming out with better options there down the road, but right now I'll say we're not offering any autonomous samplers. But I'll say my perception as an engineer is that the world of autonomy is continuing to grow. So maybe someday.
Thank you.
Sarah, did you? I think we got a couple more in the chat. Did you have any more?
That's all I've got.
Okay. So in the chat says, are you exploring how to capture soil biologic measurements with your platform? Yeah, soil health is a topic that comes up a lot these days when it comes to soil analysis, and we're currently focusing on elemental analysis, like phosphorus, potassium, calcium, magnesium, pH as well, buffer pH. But I think there's some longer term capabilities to explore there. Yeah, I'm not sure exactly what those will be, but when you get a soil analysis today, soil health metrics are one thing that some people look for. So I think we're exploring some options there. Had looked. I'm sorry, I'm not sure what green seeker is. Richard, can you clarify a little bit?
Yeah, it is an optical sensing platform that looks at I think it's NDVI or near infrared, and uses that to go in and do like fertilizer top dressing.
Okay, so this would be like a captured from a drone, you're saying?
No, basically, it's mounted like on a spray rig, and it's sensing it and adjusting the spray, how much it's applying as a liquid. And I think they had looked at doing it with a granular, and doing it on the fly and mapping it, kind of like what you guys were doing with your soil pressure maps and stuff.
Okay.
Oklahoma State had worked on it probably 15 years ago and had sold it off, but I'm not sure what is being done with it nowadays.
So I'm personally not familiar with that, but that's sort of on the go. I mean, I think that's in many ways where everyone would love to end up, is having instantaneous on the go metrics of some sort. So I'll say our platform doesn't offer anything like that right now. Between our sprayer teams, so Precision Planting's gotten into the sprayer market, and so we have essentially like a See and Spray type platform, and so we are getting more into vision systems. And then kind of like the question a moment ago about soil health metrics, there's always ongoing interest in tissue evaluation in different ways. And so maybe someday we could combine those things and have have some sort of on the go evaluation. But yeah, right now I think they're all individual pieces of technology around precision planting. But we'll continue. I mean, we're really pretty early in developing this platform in terms of expansion beyond just basic soil analysis. But we're always working on adding more capabilities. Smart Farmer, it's question in the chat. Did Smart Farmer generate real-time data, and which type of sensors were used to record the data? So yes, Smart Farmer is real time. So just like we're talking about maybe on the real-time tissue analysis of some sort. Smart Farmer is real time, and that's really what got people so excited about the maps, right? That it was generating, is that like it is a live view of your soil. Even though you cannot use that exclusively for nutrient management, that sort of on the go high resolution data is just really powerful. So what types of sensors? So it is an optical sensor that is evaluating the soil and residue as it goes by it in different wavelengths. Could your soil analysis be used in a nutrient management plan? Yes, I would say is the short answer. So we are currently offering information that is in, like I showed on the one slide, we export it to in various forms for guys to use today. People are using it today. Oh, state certified. So that makes me think of like manure management and things like that, like in Wisconsin and some other states. Yep. So we are currently not certified by like Wisconsin for manure management. Honestly, we've not really existed long enough on the open market to really seek that certification. But maybe we will. Right now, I'll say that has not being state certified has not been a barrier for the guys that are excited to get these tools. But that might be a bridge that we have to cross. So adding to the above question, have you added anything related to nitrogen management specifically, or plan to? So so no, we have not done anything for nitrate management right now, because if we that information was, it really just has limited value on a typical soil analysis, because nitrogen's so variable, or it's so time sensitive. So what we were going for are the more stable cations, but the question of nitrogen management is a huge one, right? Because it's a large part of fertilizer expense. So we're continuing to evaluate options there of what would be a useful tool. We did not really feel like it would be all that useful to once every 4 years give you a nitrogen value on a soil report. So yeah, for nitrogen, we're still evaluating what we could do to help guys with nitrogen management specifically. Lots of good questions, guys. Thanks for all the questions.
Yeah, wonderful. Thanks so much. And thanks, Reid, for sticking around for those last few questions. Before the last few of you drop off, I'll just let you know we are having more AE50 presentations. The next will be on September 13th. Daniel Bryant from Red Sea will be presenting Iris heat blocking greenhouse roof. So hope you join us then. And again, thanks, Reid.
Yes, thank you, Sarah, and thanks everyone for tuning in.
Yep. Have a nice rest of your day.
Thank you. You too.